It's 1/2 base times height. Okay? That's with a triangle. And the final shape down there, that's a parallelogram. It's also base times height. You do have to be careful when finding the height, though. You do have to be a little bit careful, because the height, by definition, has to be perpendicular to the base. Perpendicular just means that the height and the base have to form a 90-degree angle. Kind of like, and that's what this little square here is indicating. Over here, we have the same thing. The height and the base, this forms a 90-degree angle. I know I didn't put the square down there, but it does form a 90-degree angle. So for instance, this line here, this third side, this would not give you the height, because this does not form, this is not perpendicular to the base. It's not it does not form a 90-degree angle. In this triangle, same idea. This dashed line is the height, because this forms a 90-degree angle with the base. It's perpendicular to it. Whereas this side is not the height, and neither is this side. In the parallelogram, that's also what I'm trying to show you with the dashed line here. Okay? Did someone have a question? Or, oh, someone did. Yeah.
So because so because the 90-degree angle is formed like on the base, that makes like the height of the right angle that a base instead of a actual height of the triangle.
Mm-hmm, that's right. The height and the base have to form a 90-degree angle, right?
Oh.
Does that answer it, or?
Yeah, because for the one next to it, the right angle. I mean, I forgot what it was called.
This one here?
No, the left one. I'm sorry, the left.
Here?
Yeah, that one. So even if it forms a 90-degree angle, the height is the base, so it wouldn't work.
This is the height, right? And this would be the base here, and that's because this is a 90-degree angle with the base.
So it would work. So you can find the area.
Well, the area we can find, yeah, once you know what the height is.
Okay. Thank you.
Does that help, or?
I think so.
Okay, that's great. Well, I mean, we will do some examples as well. You just have to be careful when looking for the height. We'll see some examples shortly. It's a good question what you're asking. I'm just trying to show you that you have to be careful in that you can't just say, well, this side is the height, because it's not the height, because by definition, the line segment that gives you the height must be perpendicular with the base. It must form a 90-degree angle with the base of it. And that's also what I'm trying to show you down here. This dashed line would be the height of the parallelogram. I mean, the area is given by base times height, but this dashed line is the height, as opposed to the length of this side. There are more area formulas in the book, but again, you don't have to memorize any formulas, because again, you know, the tests and quizzes, they're all open book, open notes. But let's do some examples. For instance, here, notice the base is 40 centimeters, right? You know, that's the length down here. But now the question is, what is the height? Well, it's tempting to say the height is 32 centimeters, but that's not true. This is not necessarily a 90-degree angle. It's actually a little more than that. This line, however, you can see forms a 90-degree angle with the base. So this blue line is the height. So the height here is 44 centimeters. And so now we can get the area. It's 40 centimeters times 44 centimeters, which is 176 centimeters squared. And I think someone earlier asked a really good question. Why do you have square units with area? This is illustrating it generally because you're multiplying a unit of length with the same unit of length. So you're squaring the unit of length. You know, when you multiply something by itself, you square it. This is why with area, you square the unit. So again, here, the height is not 32 centimeters. The height is 44 centimeters. The line segment here forms a 90-degree angle with the base. Yeah, someone had a question?
Yeah, I just have a question. How would you find that? Like, will it always give it to you, the height, or how would you find the height?
I would give it to you.
Okay, you would get, okay, yeah, because I was like saying, like, because you said like find the area. It was, I forgot what do you call it? Yeah, it's base times height or something like that. I forgot
Right.
the formula, but I was saying like, if you don't give us the height, how do you find the height? And you said you give it to, okay.
For a parallelogram, if you have the side lanes, there might be a way to get the height. Honestly, off the top of my head, I really don't know. You might have to do some tricks with geometry, but for this class, I would just give you the height.
Okay, perfect. Thank you so much.
Okay,
Appreciate
you're
that.
welcome. Awesome question. Any other questions? Okay. So here's another one, for instance. So let's say we want to find the perimeter of this parallelogram. Notice that the side lanes, right? We know we just add up the lengths of the sides, right? They're all in the same units. They're all in centimeters.